Alrighty, hi guys. Hope you are doing well. I do miss y'all quite a bit. We are going to be finishing up notes on the transmission of nerve impulses, so you can answer that final question on your worksheet. Do make sure that you turn in your worksheet today to either the trays near the door or to Miss Ramona, or come up and give it to me if you're one of those that doesn't like to turn it into the sub. You are not having a quiz today. It's the first week back. I'm not going to do that. I'm not that mean. But you will have a quiz next Friday, okay? Hopefully next week will run a little bit smoother. I'm going to record these videos over the weekend and have them already up so you guys kind of know more or less what is going on, okay? So I am going to continue what we started yesterday. And yesterday, just as a bit of a reminder, we started talking about the impulses that your body sends, the messages that your body gets, how they're coming from different areas, how your brain receives those messages, decodes them, and sends out the message back to your body, okay? We talked about the neurons being activated, a refractory period, polarized, depolarized, action potential, okay? But today we are going to be talking about how the nerves get sent. Well, that is how the nerve. Sorry. We are talking about how the messages get throughout the body. Okay. It is going to be another shorter notes day because this part is kind of the more detailed part of the chapter. The rest of it we can breeze through, but these are the more confusing bits, so I wanted to spend extra time on it. Okay. So we've talked about the specific message. That was the nerve impulse that I was telling you about yesterday. And today we are going to be talking about the impulse transmission. So that's how messages get through the body is officially called. So impulse transmission. Okay. There are two factors that affect the speed at which these nerve impulses travel. And the first factor is the presence or absence of myelin. Remember, myelin is that fatty coating that is around the nerves, the axons of a nerve. And that myelin is a very good conductor, okay? It's an insulator as well. Okay? Because it is an insulator, it allows the action potential, what we talked about yesterday, to jump over it. So it goes from myelin sheath to myelin sheath. And this is called saltatory conduction. The jumping from myelin to myelin. Okay. Now the other factor, and this also helps with saltatory conduction, well actually inhibits it, sorry, is the diameter of the axon in the beginning. Is the other factor on how fast or how slow the message can go across it. So axon diameter, you got to think of it. Our hallways during passing periods, okay? It's really crowded. Sometimes it's hard to move through, especially if a lot of people are moving through at the same time. Now, imagine that if our hallways were even closer together, it'd be a lot harder to go through. You would have a lot of people fighting up against you or pushing, trying to get through, trying to get to where they need to go as well. Okay, it's kind of the same thing with our axons. The thinner it is, the more messages are trying to go through it and the more clogged up it gets. So the messages can't get through as fast. Now, if it's a thicker or it has a bigger diameter of if the axon has a bigger diameter, then it's easier for more messages to get through. So and the messages do get through quite a bit faster. Okay. Last but not least, and this is not a main factor, but I did want to think it is important to include in this little set of notes. Temperature can also affect the speed. So temperature can also affect the speed at which messages are able to travel. The colder it is, the longer it takes for these messages to actually move along the axons. Okay? Now, when I say that messages speed through things, I am talking about super fast, okay? Not like racing car fast. I'm talking even faster than that. Certain ones can go up to 119 meters per second. Okay, those are specifically the messages concerning where your limbs are located. So if your arms are against your side, your body is constantly checking, hey, your arm's still there? Yep, okay, let's keep them there. Or do I need to move them or anything like that? So the messages to and from the brain for this specific type of message can run at 119 meters per second. Okay. Touch can move at about 76 meters per second. So when you touch something, it takes about 76 meters. It takes the message from your finger that you're touching whatever it is with to your brain. It travels 76 meters per second. Okay. So it's still super fast. It's faster than you can see, faster than you can even really think about. But it is still slower than the messages concerning where your limbs are located. Now, pain moves the slowest, even though it seems like it's the most intense. Pain only travels at about 1 meter per second. Okay? And this is no matter where it is through the body. And even just sitting here listening to me or not listening to me, the signals concerning your senses travel about 30 meters per second. Okay, so super fast. Okay, I'll give you just a second to catch up with this. Now, the speed, like I said, depends on whether or not the axons that they travel along have myelin. Okay. And I will pull this up just a little bit so you can see. Okay, and the transmission of these senses sorry about that break. The transmission between different cells can occur at what are called gap junctions, like between your cardiac muscle fibers and the discs. But for nerves, it is different. All of the communication occurs at that synapse that I was talking about. Okay. Action potential is chemical. We talked about how they send out those neurotransmitters and everything to the next nerve through the axon terminal. But then what occurs at the I'm a little behind. Action potential is electrical. But what occurs at the synapse is chemical. Sorry, I'm turning those two around in my brain. Okay. So action potential, it is an electrical charge that is traveling through your axon. So that is electrical. However, how it gets transmitted is chemical. We release those neurotransmitters. Okay. And those neurotransmitters are what carry the message across that gap, the synaptic cleft. So what actually happens at this synaptic cleft that I've been talking about? Well, action potential, it reaches an axon terminal. So it's like, hey, I'm here. The terminal depolarizes. When the terminal depolarizes, we talked about the sodium channels opening up, but also calcium channels open up. And calcium flows in. So calcium flows into the cell. Okay. Now, also when this calcium is flowing into the cell, these neurotransmitters also flow in. Okay. They join the cell membrane. So they just kind of attach. They're in vesicles. If you remember from biology, vesicles are just kind of like shipping containers. They're for storage. Okay. And so these vesicles join with the cell membrane adjacent to the synaptic cleft. So then pores form. So little holes open up on this membrane, and they allow the neurotransmitters to diffuse in. Okay. So when the neurotransmitters diffuse into the cell membrane, that is them dropping off the message. The message then travels through that neuron or neuroglia and sends it on its way. Now, neurotransmitters can have, there's two main types. They can have excitatory, so they can make the cell happy, excited, or inhibitory. Okay, so it kind of brings it down. Examples of excitatory are like excitatory or acetylcholine, which activates muscle fibers. Endorphins, we keep talking about endorphins make you happy. Those are actually there to inhibit nerve cells. They inhibit the transmission of pain signals. That's why you can get really happy and you're not going to feel as much pain. Now the last step, sorry, I meant to leave a space here. The last step in the communication between the nerves at the synapse is the removal of the neurotransmitter. Okay? And this is usually done by an enzyme. Now, how can you remove this neurotransmitter if it is just a chemical signal between the synaptic cleft and the next, either the next neuron or the muscle fiber? Well, you have to release these enzymes. These enzymes go and they attach to whatever neurotransmitters are left in the gap, and they kind of just neutralize them. So you have all these neurotransmitters in the gap, and they're trying to get into the next cell. They're knocking at the door. They're like, hey, I need in. And the cell's like, well, I have enough already. I don't need any more. But the neurotransmitters are still there. They're still trying to get in. And so the previous cell are like, hey, we've passed on our message. We don't need to continue to try to pass on this message. So be gone. And so it releases enzymes. Those enzymes come in and they're like, hey, chill. And they just get rid of those or neutralize those neurotransmitters that are left. And so they just kind of are either taken back up or they just kind of dissipate. Okay? Give you just a second to catch up on notes. Here we are going to be talking about reflexes next, and I know that you will need just a moment to catch up on these notes. Okay, Ms. Romano, you can pause here if they need extra time. If not, here we go. So reflexes. These are very simple. They are rapid. And they are involuntary. That is the biggest part to remember. They are involuntary. That means you are not controlling them. That's why when a doctor hits your knee jerks out. It's because it is a reflex. You are not controlling it. And this happens in both the CNS and PNS. Both have different structures that can control it. Now, there are two types of reflexes. The first type is called somatic. Okay, now I'm going to scroll up just a little bit so you can see that. Somatic reflexes, and these involve your skeletal muscles. So if you touch something hot and you pull your hand back really quickly, that is a reflex. A somatic reflex, so you're moving your skeletal muscles to prevent your skin from burning either further. Okay, and then there are autonomic reflexes. Okay, and these are, oh, apparently I can't spell still. Reflexes. Okay, and these are involuntary stimuli to cardiac muscle. And the smooth muscle in your organs. So these are the ones that tell your heart to beat all the time. You are not constantly thinking about it. That also tells your stomach to, hey, you need to continue digesting. You need to move a little bit to help with that. Digestion, elimination, so pooping or peeing, sweating, and your blood pressure are all activities that are regulated by these autonomic reflexes. Alrighty, ladies and gentlemen, that is going to be it for today. I hope you had a good day. I hope that this is helping a little bit rather than just bookwork and watching What's-His-Face do the super fast ones. If you have any suggestions or comments, please let me know on the Padlet. Otherwise, have a wonderful weekend. I miss y'all a lot and have a good day. Bye.